All right, you guys, everyone's favorite, we need to write a direct variation equation for the gallons of water based on the number of minutes. So I can already kind of write it without the K, right? I know my gallons is equal to K, some constant of variation, times N, my number of minutes. Then I just need to substitute in some numbers here. I have a 30-gallon bathtub and I have 12 minutes. This will help me find my K. So I have 30 equals K times 12, right? If I divide both sides by 12, then my constant of variation is equal to 2.5. So my actual equation, so this is like the outline of my equation. For my actual equation, I needed K. My actual equation is going to be G equals 2.5 times N, where G is my gallons, number of gallons, number is number of gallons, and N is my number of minutes. Okay, so that means for every minute, for each minute that the water is running, the bathtub fills up with 2.5 gallons of water. So my total gallons is equal to those two numbers multiplied together. Let's go on to the next one. Oh, you guys, these are great. Which one shows an inverse? So which one of these shows an inverse and which one of these shows a direct? So a direct variation, we know that our x times y is going to equal our constant of variation. And with an inverse, we know, oops, I did that wrong. I hope you guys caught that. Our direct variation means that every time we take y and divide it by x, this is why we got to study this stuff, we're going to get our constant of variation, right? And then over here, if we take our y times our x, we will get our constant of variation. And remember, this is because over here, y equals k times x. So if we solved for y, we would have to divide by x. And over here, y equals k over x. So if we solved for k, we would have to multiply by x. So that's how that works. So if we take it gives us our constant of variation, the number. So over here, obviously it's going to be multiplied together right here. And on this side, it's going to be, they were tricky with them. It's going to be this one. It's going to be this one where we have k. So they just wrote it backwards. They wrote it backwards like this instead of like this, okay? So they wrote it with the b equals a times your k, and there's that direct variation right there. So just be careful when you're going through your questions that you're reading them and know which one it wants. Let's see what's next. A meat grinder can grind 5 pounds of sausage in 7 minutes. Write 3 proportions that can be used to find x. 3 different one. How long it would take the grinder to grind 28 pounds of meat. So let's see. If it can grind 5 pounds in 7 minutes, And don't forget, when a question's asking you to write this stuff, you have to write your units here. So 5 lbs, 5 pounds in 7 minutes, is how many minutes for 28 pounds? And remember, for a proportion, lbs, the pounds both have to be on the same side and the minutes have to be. So there is one way I could do it. You guys, I could just flip both of these over and get the same answer. So I could put, here's a second way, I could put 7 minutes on the numerator, 5 pounds on the denominator. Oops, sorry, I started to do a direct variation there, didn't I? Nope, easier with a proportional, and it's asking us for a proportion anyway, is equal to x minutes over 28 lbs. That does not look like lbs, but you just have to trust me. And then why don't we find a unit rate, right? If it's 5 pounds per minute, 5 pounds for 7 minutes, how much is it for 1 minute? So if you divide 5 by 7, you get 1.41 pounds. You get here's our unit rate, 0.41 pounds for 1 minute. And then how many is that? How many minutes is that for 28 pounds, right? lbs. Great, there's 3 right there. I'm sure there's a couple more that you guys could come up with. Let's see, what's next here? A Brooklyn feline named Samson weighs in at a hulking 28 pounds, making him New York City's biggest cat. However, contender for the world's heaviest cat, 5-year-old Katie, who lives in Russia, reportedly weighs 28 kilograms. Prove with mathematics which cat is heavier. So I think let's just change, and this question is going to require some writing at the end so that you can write down what you found. You can either change Samson from pounds to kilograms or Katie from kilograms to pounds, and so you only need to do it one way to figure out, to get that direct comparison. Oh, the kilograms to pounds can be found on the very first page where it has the conversion chart for you. I went ahead and did that. I'm just going to set it up for you guys and you can solve it and tell me who it was. But I know that what it tells me on the conversion chart is 1 pound is 0.454 kilograms. Okay, so I want to know, I could do this either way. I could put either Samson on this side, so I would put 28 here and X here, or I could put Katie on this side and I would put 20, oops, I still have my eraser on. I would put, why can't I work this thing? I would put 20 here on the denominator. And then on the numerator, I would put X because we want to know how many pounds she is. So either way you want to do it, you come up with an answer and you put it as which cat. So this cat, and I didn't find the answer. I'm going to make you do that. You would put their name here, though. This cat weighs however many kilograms or pounds, and the other cat weighs however many kilograms or pounds, and you say which weighs more because I solved using a proportion. All right, you guys, was that the last question. Oh, there's one more question. Which table has an inverse variation? So which table do I take the x times the y and I get the same number each time? I get k each time. 5 times 2 is 10. Let's take a look at this one, right? 5 times 2 is 10. 5 times 10 is 50. So this is not it, right? 5 times 1/5. 5 times 1/5. What does that equal? I have to put a 1 here so I can multiply my fractions. 5 times 1 is 5. 5 times 1 is 5. 5 over 5, so that equals 1. 10 times 1 over 10 over 10. Put a 1 here. And then you get 10 over 10, which is 1 again. 15 over, I think you see the pattern here. It is going to be this one. Okay, get a good night's sleep, eat a good breakfast. We'll see you tomorrow.